Namaste students, welcome back to my channel. Students, today in this video we are going to study the bonding in the coordination compound. The bonding in the coordination compound was first studied by Alfred Werner in 1892. So the bonding in coordination compound, that is how the bonding takes place in the coordination compound, was first studied by Alfred Werner in 1892. Alfred Werner in 1892. Now, in 1892, Alfred Werner produced a number of complexes by the reaction between COCl3 and ammonia. Means Alfred Werner ने 1892 में COCl3 and ammonia की reaction करवा के number of complexes बनाए. Those complexes were COCl3.6NH3, COCl3.5NH3.H2O, COCl3.5NH3, COCl3.4NH3, COCl3.3NH3. So वर्नर ने क्या किया? वर्नर react COCl3 with NH3 and produces a number of complexes, produces these complexes. Further, when Werner react these complexes with the excess of AgNO3, chloride ions are precipitated in the form of AgCl. उसके बाद जब वॉर्नर ने इन कॉम्प्लेक्सेस की रिएक्शन एक्सेस ऑफ AgNO3 के साथ कराई तो उन्होंने क्या देखा? That chloride ion are removed in the form of, or chloride ion are precipitated in the form of AgCl. But when he calculated the conductivities of different solution, जब different solution की conductivities को measure किया गया, the conductivities of different solution comes different. जो different conductivities, जो solution की conductivities थी, वो हमारी क्या थी? Different. Now the reason behind this is that after the reacting with AgNO3, the solution which we get contains different ions. आ रहा है कुछ समझ में? First, Werner reacts COCl3 with NH3 and form these complexes. Then Werner react these complexes with excess of AgNO3 and observe that some of the chloride ion are precipitated in the form of AgCl. Now, if we see in all these reaction, we have 3 chlorine. And we are saying that the chloride ion is precipitated in the form of AgCl. If chloride ion is precipitated in the form of AgCl, we have to get equal number of ions. हमें equal number of ions मिलने चाहिए. एक आयन हमें CO और 6NH3 का मिलेगा, एक 3 आयन हमें Cl के मिलेंगे. Similarly, 1 ion is of CO, 5NH3, H2O, and 3 ions are of Cl negative. 1 ion is of CO, 3NH3, and 3 ions are of Cl negative. It means number of ions हमारे क्या होने चाहिए? Same. But when he calculated the conductivities of different solution, the conductivities of different solution comes different, which shows that the number of the ions which are present in the solution are different, and which also shows that in all the complexes, in all the compounds, all chlorine ion will not precipitated in the form of AgCl. सारे के सारे chloride ion जो है वो precipitate नहीं हुए हैं in the form of AgCl. Now, in this case, when it reacts with excess of AgNO3, we get CO6 CONH3 whole 6, 3 positive, 3 Cl negative. Here we get CONH3 whole 5, H2O, 3 positive, 3 Cl negative. Here we get CONH3 whole 5 Cl 2 positive and 2 Cl negative. Clear? Now in third reaction, instead of 3 Cl negative, we get only 2 Cl negative. हमें सिर्फ क्या मिला? 2 Cl negative. In this CO NH3 whole 4 Cl2 positive Cl negative, and in the last we get 0 Cl negative ion. क्या मिला? 0 Cl negative ion. Now in this we have 4 ions. In this we have 4 ions. In this we have only 3 ions. One is this one and another one is this one. In this we have 2 ions, and in this we don't have any ion, and this is electrically neutral. This is electrically neutral. And how we get to know that yes, we get different ions due to the difference in conductivities. Difference in conductivities. Clear? Now through this experiment, इस experiment के basis पे Werner gave a theory which is known as Werner's theory of the coordination compound. The main postulates of the Werner's theory of the coordination compounds are, the first postulate था, the very first postulate is the metal atom in the coordination compound. The metal atom, the central metal atom has 2 valencies. In the complex, the central metal atom have two valencies. दो valencies होती है, primary valency and secondary valency. Primary valency and secondary valency. Now primary valency को कैसे define करेंगे हम? When the central metal atom is present in the form of simple salt. When the central metal atom is present in the form of simple salt, at that time the number of the atoms which are present around that particular central atom, that is its primary valency. वो उसकी प्राइमरी वैलेंसी होती है. सो जब मेटल अपने सिंपल सॉल्ट में प्रेजेंट होता है, उसके अराउंड जितने भी एटम्स होते हैं उसको हम उसकी क्या कहते हैं? प्राइमरी वैलेंसी. फॉर एग्जांपल, दिस इज अ कॉम्प्लेक्स and this complex is formed by the reaction between COCl3 and NH3. So here cobalt is the central metal atom and here COCl3 is present in its simple salt form. ये COCl3 का simple salt form है and this is the complex form. Now in this case the cobalt is surrounded by 3 chlorine. So its primary valency is 3. Clear? So primary valency क्या है हमारी? Primary valency, the number of the atoms which are present around the central metal atom when it is present in the form of simple salt, that is its primary valency. वो उसकी primary valency होती है. Secondary valency क्या है हमारी? Secondary valency is when it is present in the complex ion. When it is present in the complex ion. When the central metal atom is present in the complex ion, then the number of the atoms which are present around the central metal atom, that is its secondary valency. वो हमारी secondary valency होती है. Like this. In this is cobalt and this is surrounded by 6 ammonia. So that's why its secondary valency is 6. Primary valency is 3 and secondary valency is 6. This thing is clear, beta? Now, the second postulate. What is the second postulate? The metal had the tendency to satisfy both the valencies. Tendency to satisfy both the valencies. Clear? मेटल जो होता है उसकी टेंडेंसी होती है कि वो दोनों वैलेंसीज को क्या करता है? सेटिस्फाई. बट द प्राइमरी वैलेंसी इज सेटिस्फाइड बाय एनायनिक स्पीसीज. प्राइमरी वैलेंसीज को कौन सेटिस्फाई करता है हमारा? एनायनिक स्पीसीज. प्राइमरी वैलेंसीज आर सेटिस्फाइड बाय एनायनिक स्पीसीज, but the secondary valencies are satisfied by either anionic species or by neutral molecules. Clear? Now here primary valency is Cl and it is in the form of Cl negative. ये Cl negative के presence में, so that's why the primary valency is satisfied by anionic species. In this case NH3 is a neutral, therefore it is neutral. And if I see this equation, that is CONH3 whole 5 Cl. Now the 5 valencies are neutral and the 1 valency is anionic. So primary valency को कौन satisfy करता है? Anionic species. But secondary valency को anionic species के साथ साथ कौन satisfy कर सकता है? Neutral species as well. And nowadays this primary valency is known as oxidation state and the secondary valency is known as coordination number. जो present scenario है वहां पे हम लोग primary valency को, जो वार्नर ने प्राइमरी वैलेंसी कहा था, उसको हम ऑक्सीडेशन स्टेट के नाम से जानते हैं and the secondary valency is in the name of the coordination number. These two postulates are clear, beta? The central metal atom has two valency, primary valency, which is the number of the atoms which are present around the central metal atom when it is present in the form of simple salt, or when it is present in the form of complex, then the number of the atoms around that central metal atom is secondary valency. Primary valency is satisfied by anionic species and the secondary valencies are satisfied by anionic as well as the neutral species. Clear? Now the third postulate is the secondary valencies. The atoms, the secondary valency is arranged in a fixed position in space around the central metal atom and hence determine geometry. Clear? The secondary valency around the central metal atom is fixed in a definite position in a space and that fixed position determine the geometry of the coordination compound. वो हमें क्या बताती है? जो शेप है, जो ज्योमेट्री है कोऑर्डिनेशन कंपाउंड का, वो हमें बताती है. सो सेकेंडरी वैलेंसीज आपकी एक फिक्स पोजीशन पे आपकी अरेंज रहती है और वो हमें बताती है कि कैसे आपका कोऑर्डिनेशन कंपाउंड की ज्योमेट्री होगी, कैसे आपके कोऑर्डिनेशन कंपाउंड का शेप होगा. सो दीज आर द पोस्टुलेट्स ऑफ द वर्नर्स कोऑर्डिनेशन थ्योरी. These are the postulates of Werner's coordination theory. Now, on the basis of the postulates and on the basis of the different studies, okay, Werner observed something. What are those observations? Those observations are, first thing, if we look at this complex, in this complex, we get the property of the chloride ion. But we didn't get the property of the CO3 positive and NH3. It means when the complex is present, means when the atoms are present within the coordination sphere, they lose their identity. It means this complex behave like a complex. It doesn't behave like a CO3 positive or NH3. Clear? जब आपका एटम्स कोऑर्डिनेशन स्फीयर के अंदर आ जाते हैं तो वो अपनी आइडेंटिटी को क्या कर देते हैं? लूज. Here these chlorine behave as a chloride ion, but in this chlorine lose the identity of the chloride ion. ये अपनी आइडेंटिटी को लूज कर देगा. Now it will not behave like a chloride ion. It will not show the property of the chloride ion. So when the atoms are present in the coordination sphere, they lose their identity. This thing is clear, beta? This is the experimental study of the Werner, and these are the postulates. Now we'll study the limitations. So the limitations of Werner's theory, the very first limitation is why some elements form coordination compounds. Why only some element forms coordination compounds. We have almost 118 elements in our periodic table, and all the elements are not able to form the coordination compounds. If we neglect the noble gases, that noble gases are non-reactive but other have to form the coordination compound, but only few element forms the coordination compound. So Werner will not able to explain that why only some elements will form the coordination compound. Second, Werner will not able to explain that why coordination sphere has a definite geometry. Why coordination sphere has a definite geometry. Definite geometry means according to Werner, that the secondary valencies are arranged themselves in a fixed position in a space and they represent the geometry, but Werner is not able to explain that why they are arranged in a fixed position in the space. So Werner will not able to explain that why coordination sphere has a definite geometry. Third, Werner will not able to explain that why these compounds, means coordination compound, why coordination compounds have definite magnetic and optical properties. Magnetic and optical properties. Optical properties. So these are certain limitations which Werner theory will not able to explain, and to overcome these limitations we have a number of theory like valence bond theory, crystal field theory, and which we will discuss in the next video. So these are the different limitations. So Werner theory, first the experiment of the Werner, second the different postulates of the Werner, and third the limitation of the Werner. So that's all for today. I'll see you in my next video.